Hi students, in today's session we are going to discuss about friction. Friction அப்படினா என்னமா? Whenever there is a plane surface and an object is moving on that plane surface, and the move ஆகிற object பாத்தீங்கன்னா it will experience an opposing force and that is termed as friction. அது பாத்தீங்கன்னா it is in between the object and the surface இருக்கக்கூடிய ஒரு விதமான opposing force ன்னு சொல்லலாம். So object in the direction la pochuna, in the opposing direction la the force will act. So if in case the force acting on the object which is making the object move in this direction, gain an acceleration in this direction, in that case the frictional force F will act in the opposite direction. So friction can be described as a force that opposes motion. And idanude classification pathina, you have it as dry friction and wet friction. Two categories. Idhula major nama paaka pora category is dry friction. Wet friction radhu paathona between particles irukakodiya oru vidhamana friction. So this wet friction is caused due to continuous collisions of particles of a given medium. For example, you can say air friction is an example of wet friction. Ipo, this wet friction is not our consideration. We are bothered about dry friction. Adhaadu or object it is moving on a surface abdin sonna, this dry friction comes into play. This dry friction is due to irregularities of surfaces in contact. So in the dry friction, how this is applied abdinradha we'll see now. So to understand dry friction, let us imagine this is a surface. This is a rough surface. In the rough surface mela, there is an object placed. Okay. So in the object ko in the surface ko nadula irukakodiya contact. Okay. So adula oru portion mattum, if in case you enlarge it and see, you can see that it will be like this. Object inga irukku appdin sonna, the surface will be like this. So idhula over point in contact la irukkiradhu pathina, it will be actually minimum compared to that of the entire lot. Adhaadu and the entire object and the entire surface oda contact la irukadu, but rather at specific points la da contact la irukum. Appo அந்த point la mattum irukakodiya pressure adhigama irukum. In the contact points la irukakodiya interlocks, they oppose the relative motion between these two surfaces. In the interlocks nala, at every point of contact la pathina, contact forces are developed in various directions. Ipo in the point la pathina, in the direction la, like that various directions la contact forces are developed. Ipo in the each and every force, contact force, I can resolve it into its components. Either vertical component, either horizontal component. Same way, either vertical component, in the force ke either horizontal component. Illaya? So, in the mari the components are resolved panona, vertical components ella enna pannuna, in the object irukku illaya, this object of mass m, in the object oda mass vertical balance pannum. Whereas in the horizontal component of contact forces irukku illaya, idu ellame together it will actually give a cumulative effect, and that cumulative effect is called as the friction. So friction radhu enna, it is contributed by the horizontal components of the contact forces. So, if our object, if it is placed on a surface, and the surface mele irukkiradunala, it will experience a normal in the upward direction and the frictional horizontal component in the horizontal direction. In the rendu forces ku nadulayana resultant is nothing but the resultant of all the contact forces put together. So, inge in the horizontal component da friction nu solrom. So, dry friction is nothing but the frictional force which is exerted because of the contact between the two surfaces. Idanuடைய various types enna அப்படின்றது தான் நம்ம next பார்க்க போறோம். So, the major types of friction பாத்தீங்கன்னா static friction and kinetic friction னு சொல்லலாம். இது ரெண்டுத்துக்கும் நடுவுல intermediary level இருக்கிறது தான் இந்த limiting friction. Static friction, as the name implies, when the object is at rest, this is acting. and when the object is in motion, this is acting. இது ரெண்டுத்துக்கும் நடுவுல எப்ப ரெஸ்ட்ல இருந்து மோஷனுக்கு மாறுதோ அப்ப இருக்கக்கூடிய amount of friction தான் it is called limiting friction. So for example, there is an object placed on a surface. Okay? In the object or the mass, let me take it as m. Because of this mass, it will experience, the table will experience a force in the downward direction which is nothing but mg. And normal to this upward direction la n அப்படின்ற ஒரு force act ஆகும். கரெக்டா? இப்போ there is no external force acting on this object. அப்ப frictional force எவ்வளவுமா? You can say friction is 0. ஏன்னா external force எந்த அளவுல act ஆகுதோ அதை oppose பண்ற அளவுல தான் frictional force will act on the object. Okay? So, mass of the object nala downward direction இருக்கக்கூடிய force அதுக்கு opposing direction which is normal is acting in the upward direction and there is no frictional force when the object is at rest. இப்போ now I am going to apply a force. Okay? ஒரு amount, ஒரு particular amount of force apply பண்றேன்னு வச்சுக்கோ. For example, ஒரு 5 Newton apply பண்றேன்னு வச்சுக்கோ. Object move ஆகுமா? Move ஆகாது. Because அதனுடைய mass அதிகமா இருக்கிறதுனால இந்த particular 5 Newton force will not move this object. But in the opposing direction, this object will face a frictional force. The frictional force will also be of 5 Newton which is equal to that of the force applied. So in the frictional force, you call it as static frictional force. So இது ஏன் static friction? Now object இன்னும் நகரவே இல்லை. Imagine now I am giving a 15 Newton force. 5 Newton க்கு பதிலா 15 Newton force கொடுக்கிறேன். And இந்த அளவு force கொடுத்தா object just starts to move அப்படின்னு இருக்குன்னு வச்சுக்கோ. கொஞ்சம் கொஞ்சமா force increase பண்ணிட்டே at some point 15 Newton force அப்போ object just about to start motion. அப்படின்னு இருக்கிற அந்த particular timeல இருக்கிறது தான் இந்த limiting friction அப்படின்னு சொல்லுவோம். So this limiting friction is nothing but maximum of static friction னு சொல்லலாம். So Fs oda maximum value that is possible is nothing but called as limiting friction. Static friction rather Fs max is limiting friction and Fk is termed as kinetic friction. So in the kinetic friction எப்ப வரும்னா இந்த 15 Newton force apply பண்ணி நகர ஆரம்பிச்சிருச்சு பாத்தியா? So நகர்ந்துட்டு இருக்க அதாவது movementல இருக்கிற object experience பண்ற friction தான் kinetic friction. In the Fs max, அதாவது limiting friction oda value, it depends upon two factors. So the first factor பாத்தீங்கன்னா, it is nothing but the normal reaction between the two surfaces, this normal reaction. And the second factor is nothing but the roughness between the two surfaces. So in the limiting friction value, அதாவது Fl or Fs max, I can say it is directly proportional to the normal reaction. And in the proportionality constant I எடுத்துட்டு வருது Fl is equal to, I am saying it is mu s into n. And this mu s is nothing but called coefficient of static friction. In the coefficient of static friction பாத்தீங்கன்னா, it is dependent upon the roughness of the surface. So please understand, limiting friction, அதாவது Fl value பாத்தீங்கன்னா, it depends upon two things. ஒன்னு normal value, இன்னொன்னு roughness. So normal அப்படின்றதுக்கு I am saying Fl is directly proportional to n and இதனுடைய constant, proportionality constant I am bringing in mu s, and mu s is called as coefficient of static friction and the value of this mu s depends upon the roughness of the surface. So roughness பொறுத்து இந்த mu s value will vary. So problems la they'll actually give you the value of mu s for a given surface and accordingly they'll ask you to calculate the limiting friction value. So here is a problem to illustrate about static friction, coefficient of static friction. இப்போ இந்த mu s value between these two surfaces, see there is a block on a surface. So in the block oda mass m and in the ரெண்டு surfaces க்கு நடுவுல இருக்கிற இந்த coefficient of static friction is given as 0.2. Now we are going to find out how much force is required to move this object. Okay? So mass வந்து 10 kg. Imagine a force is acting in this direction. Let me denote it as capital F. So in the force வந்து இந்த directionல act ஆகுதுன்னு சொன்னா அதுக்கு opposing force அதாவது Fs frictional force, static frictional force will act in the opposing direction இல்லையா? So majorா பார்த்தோம்னா because of the mass actually downwardல you will have a force mg acting on the object and அதுக்கு opposite directionல equalா ஒரு force which is nothing but the normal will act in the upward direction and it is exerted by the table on that object. Correcta? So, in the normal அப்படின்றது it is nothing but the actual force in the vertical direction which is happening. So, problem என்னமா பார்த்தோம் previous pageல we discussed that limiting friction FL is nothing but equal to mu s into normal அப்படின்னு பார்த்தோம். இப்போ இந்த normal அப்படின்றது it is nothing but equal and opposite for mg. Correcta? அப்போ இதோட magnitude என்னமா n will be equal to mg. So, I can write it as mu s value எவ்வளவுமா 0.2 into m value எவ்வளவு 10 and approximately let me take g oda value acceleration due to gravity 10 ன்னு எடுத்துக்கலாம் instead of 9.8. So this is 100 into 0.2. How much it will be? 20 Newton. So the limiting friction force is 20 Newton for this scenario. So imagine initially the force that I am applying is equal to 5 Newton. 5 Newton apply பண்ணா எனக்கு the limiting friction அதை cross பண்ணுமாமா கிடையாது. The limiting friction is what? 20 Newton. So the frictional force, static friction that will happen here will also be equal to 5 Newton and the object will be at rest. There will be no motion. ஆனா அதுவே if in case the force applied is equal to 20 Newton, imagine exactly 20 Newton தொட்டுருச்சுன்னு சொன்னா in that case this object can overcome the normal force as well as the static friction between the surfaces and thereby it can start moving. அதுதான் the limiting friction concept. So 20 Newton இருக்கும்போது என்னோட Fs force now will become equal to Fl which is nothing equal to 20 Newton and therefore the object starts to move. So this is the scenario. In the mu s அப்படின்றது it depends upon the surface. Specific for this object and this surface. இந்த ரெண்டு surfacesக்கும் நடுவுல இருக்கக்கூடிய அந்த value of mu s is what? 0.2. So roughness of the surface on which the object is moving and the roughness மேல depend ஆகிறது தான் இந்த mu s value. So for different surfaces mu s value will be variant. So here we see about kinetic friction. Kinetic friction அப்படினா என்னமா? Because of the motion of the object அதை experience பண்ற friction தான் kinetic friction. So there is a rough surface imagine and there is an object on top of it and it is moving in this direction with a particular velocity v. Okay? So in the object of mass m பாத்தீங்கன்னா in the downward direction for sure mg ன்ற ஒரு force it will be acting. So அதுக்கு opposite direction it will have a normal force acting. Correct? So force of friction here the kinetic friction value that will obviously act in the opposing direction. So Fk will act in the opposite direction and as usual we know that the friction's value is dependent upon what? The mg value. That it depends upon the normal. So I can take the kinetic friction to be directly dependent upon the normal. So directly proportional அப்படினு எடுத்துக்கிட்டோம்னா இங்கேயும் proportionality constant remove பண்றதுக்காக யூஸ் பண்றதுதான் Fk is equal to mu k into n. So அங்க எப்படி இது coefficient of static friction of mu s அதே மாதிரி இங்க it is coefficient of kinetic friction. So here there is one interesting concept ma. We have been discussing about the static friction or maximum value of static friction which is limiting friction and இப்ப நம்ம discuss பண்ணது it is kinetic friction. இது ரெண்டுத்துல எது அதிகமா இருக்கும்? Which will be greater? It will always be the limiting friction. You might be thinking, ma'am, kinetic friction இது move பண்ணணுமே அப்ப இருக்கக்கூடிய friction move ஆகும்போது இன்னும் அதிகமா தானே இருக்கும். But it's no. Limiting friction value தான் அதிகமா இருக்கும். Kinetic friction value once after the object starts moving, motionல இருக்கிற ஒரு objectக்கு the kinetic friction value will be lesser compared to that same object when it is at rest இருக்கக்கூடிய limiting friction. Why? Because அப்படினு பார்த்தோம்னா previousா concept பார்த்தோம் இல்லையா இந்த rough surfacesக்கு நடுவுல இருக்கக்கூடிய interlocks and the interlocks nala and the contact forces that it is exerting this particular limiting friction அப்படினு பார்த்தோம். இப்போ ஒரு ஆப்ஜெக்ட் மூவிங்ல இருக்கு அப்படினு சொன்னா அப்போ the number of interlocks பாத்தீங்கன்னா it will be less. The less number of interlocks leads to lesser value of kinetic friction. So kinetic friction is lesser compared to that of what? The limiting friction.